Electricity, how vital it can be, is known when you don't have it. So how do we make electricity, this mighty thing that lights our dark world? Well, to begin with, it starts with the littlest thing we call atom. It is so little that we cannot actually see it. Matter is formed of atoms, which arrange together as molecules. An atom, made from three main parts, protons, neutrons, and electrons, is the center stage for electricity. This representation here is the Bohr model, also known as the planetary motion model. The Bohr planetary model is perhaps not too accurate, but since for the basics they would do, the actual motion is for some other time to discuss. At its center is the nucleus. This is where you will find the protons and neutrons. Protons are positively charged and neutrons, as the name suggests, have no electrical charge. Electrons are negatively charged and circle the nucleus. It is the electrons that are responsible for the flow of current, whereas the presence of protons decides what type of atom it is going to be. A typical material would have the same number of protons, but electrons and neutrons will vary. The negatively charged electron is held in place by the positive charge of the proton in an atom in a stable neutral electric state or zero electric charge. This is because unlike poles attract, and like poles repel. It is this opposite attraction that forces electrons to move from place to place, atom to atom, pulling toward the positive proton in an atom within either the same material, or even different material. In other words, by making an atom gain or lose electrons, we can change the charge of a particular atom. More protons in an atom is making it positively charged, lesser protons is a negatively charged atom. Nature seeks to find stability, hence the movement of electrons back and forth. It is this flow of electrons that allows electricity to be transferred, the flow that we call current. Give you an example, when you rub your feet on a carpet you lose electrons, you then touch stable metal, and in an instant, you feel the spark. That is because you have become electrically unstable. By transferring electrons to the carpet, when you rubbed your feet into and with the positive charge and the metal electrons jumped onto your negatively charged body upon contact, metal being a good conductor. On a small scale, such a contact would trigger a little spark. On the large scale, this static discharge creates the weather lightning phenomenon, put very simply.
Now, the basis for an efficient flow of electrons depend on the type of materials. For example, metals like copper allows easier flow of electrons, and that is why, as we mostly know, they are known for being good conductor of electricity. So when electricity is in fact the flow of electrons, how do we make this happen? You've got to start with something that creates the flow. Think of anything? Of course you can. A battery starts with a chemical reaction inside of it that forces a collection of negatively charged electrons to one side. The other side has the consequent positive charge left in it, meaning that for a current to flow there must be a positive-negative charge separation on the 2 points between which the current must pass. The negatively charged electrons would want to pull back to the positive side, so when you connect both sides with a good conductor, the electrons will flow. Somewhere in there a bulb will light up too. Flow of electrons is current, which is a measure of the number of electrons flowing per unit amount of time. Electrons are tiny. We can't measure them all, so instead we choose to measure the bunch in coulombs, which again is a really huge number of electrons. So to make it simple, the number of coulombs moving per second is more convenient to tape. It is then called the amperes, or the amp. 1 coulomb per second is 1 amp. You can't miss the amp value printed on a lot of those devices we use every day. So is that enough? A whole lot of coulombs bunched together in an amp going somewhere? Can they be tasked to get some work done? Yes, they can be, and that is where the term voltage comes right in. In the next lesson, more of this stuff will be taken up. For now, the applicants must get into the greatest simplicities of the contents covered on this video and gain up on related topics. Good luck.